All right, you are welcome again. Today we are still considering Laplace transform. And under Laplace transform, let's take a look at the basic properties of Laplace transform. And then in our previous video, we treated one of the properties called linearity property. And then in this video, we're going to take another property called first translation or shifting property. We say first translation property or first shifting property. Okay, first translation property, or we say first shifting property. Now, what does this property state, or what is this one all about? This property states that if the Laplace transform of f of t is equal to f of s, then the Laplace transform of e raised to the power of at f of t is going to give you f of s minus a. Hello, this is called the first translation or shifting property. Now let's go. Please pay attention. We are going to explain this in details so that you will not be confused. All right, now let's go. First of all, by definition, what is Laplace transform of a function f of t? The Laplace transform of a function f of t, by definition, is the integral from 0 to infinity e raised to the power of minus st f of t dt. Okay, and then we'll say when we perform this, let's call our result, the outcome, let's call it f of s. Now this f now is in small letter. Okay, f of s. Some people can denote this outcome as f bar of s, but I choose to use this notation. Okay, anywhere you can see f bar of s is still the same thing. All right, that is telling you that it is the product you performed Laplace transform operator on a function, and the outcome is this. All right, good. Now let's go. By definition, we have defined this, and we said that the Laplace transform of a function f of t is given as the integral from 0 to infinity e raised to the power of minus ht f of t dt. And then we say, let's call it the product or the outcome. Let's call it f of s. All right, good. Now let's go. Now, by this definition, when you have a function, or when you have a problem like this, the Laplace transform of e raised to the power of at multiplied by your function f of t, what is it going to give you? Now look at this. That means we are going to say, by definition, it's going to be the integral from 0 to infinity e raised to the power of minus st. Now, in place of f of t now, we have e raised to the power of at f of t. That is the function we are to do what? We are to integrate. Okay? Now, carefully look at this. E raised to the power of at is not a constant because it is having the variable what? T. Okay? So adibin is a constant. We could have just taken it behind the integral sign like the linearity property. But here, it's having the variable t. It's not a constant. All right? Good. Look at what we do. Let's open this bracket. When we open the bracket, and then here we are going to say that we have e raised to the power of minus st multiplied by e raised to the power of at. Okay? Applying the law of indices, we are going to add their powers. Okay? We're going to add their power. Now, look at this. Adding their power, we're going to have the integral from 0 to infinity e raised to the power of minus st plus at. Then we have our function f of t dt. All right, good. Now look at the exponential or the power. Our variable is t, okay, and it appears in two places. Let's factor out the t. What do we have next? So factoring out the t, we are going to have the integral from 0 to infinity e raised to the power of minus s plus a in bracket t. Hello, minus s plus a in bracket t. All right, then we have f of t dt. So now look at this again. Let's do something to the power once again. What do we do? Let's factor out minus, okay? Because based on our definition, we have minus st, all right? But in this case now, minus is inside. Let's factor it out. So when we factor it out, we are going to have minus s minus a in bracket t. So here we are having the integral from 0 to infinity e raised to the power of minus open bracket s minus a close bracket t, then multiply by f of t dt. All right, good. Now look at this again. Look at what we're going to do. We're going to say let this s minus a in the exponent or in the power, let's call it a letter. Let's call it, let's say p. Okay, so here we say let s minus a be called a letter p. All right, good. So when we call it a letter p, what do we have now? We have the integral from 0 to infinity e raised to the power of minus. In place of s minus a, we write p. Okay, so we have minus pt f of t dt. We still have our variable t, right? It's untouched. Good. Now, based on definition of Laplace transform, we said that the Laplace transform of a function f of t is given as the integral from 0 to infinity e raised to the power of minus st f of t dt. And then we say is the same as saying f of s. Okay? F of s. Where do we get this s? Is from the parameter in the exponent of e. Hello, we have e raised to the power of minus st. T is a variable and s is a parameter. So here we say is f of s, which is a parameter. Is that clear? Good. Now coming to the function we just obtained now. The function we just obtained now, the parameter is what? Is p, and a variable still remain the t. All right, good. So now we have the integral from 0 to infinity e raised to the power of minus pt f of t dt. So it's going to give us f of p. Hello, it's going to give us what? F of p, because by definition, when you have e raised to the power of minus st f of t dt, it gives you f of s, because s is the parameter. In this one we just solved now, our parameter is p. Okay, now in our first video on introduction to Laplace, I gave you so many notations you can use in Laplace. Is that true? Yes, there are some notations. So whenever you see it, you should know that this is talking about Laplace transform. Please, I want you to watch that video, introduction to Laplace part 1 and also part 2. Now let's continue. Good. Here we have the integral from 0 to infinity e raised to the power of minus pt f of t dt, and then we say that is equal to f of p. Is that true? Yes. But what do we say that p is? We say that p is s minus a. Is that true? Yes. We say that p is s minus a. So now in place of p now, we can write s minus a. So that means we're going to say that the integral from 0 to infinity e raised to the power of minus pt f of t dt is equal to f of s minus a. You remember that this s minus a is the same as p. All right. So here the proof, we have proven it, that the Laplace transform of e raised to the power of at f of t is the same as f of s minus a. This is called first translation or first shifting property. Hello. Yes. Thank you very much. We are talking about the properties of Laplace transform. We have treated the first property. This is the second one, and consequently, we are treating more of them. Please keep watching the properties. Let's get ourselves familiar with this course. All right, Laplace transform. See you next time. Thank you very much. Please, if you have yet to subscribe to our YouTube channel, please do us a favor. click the subscribe button, give this video a thumb up if you like it, okay, and then share to your friends. Thank you and stay blessed.